How secure are your Docker containers, and why does it matter? Imagine your applications are like valuable treasures stored in a safe. Docker containers are a popular way to pack and run these treasures. But how safe are they really? That's what we're here to find out. Docker containers create a kind of isolated environment by bundling applications and their dependencies together. This isolation helps keep each container separate from others and from the host system. When containers run as non-privileged users instead of the root user, they are less likely to be exploited. However, their security depends on how they are set up and managed. One big thing to remember is that Docker containers share the host operating system's kernel. This means if there's a vulnerability or misconfiguration at the host level, all containers on that host could be affected. Securing the host operating system by applying patches and using a minimal, hardened version reduces this risk. Using dedicated hosts for containers instead of sharing with other workloads also helps keep things safer. The images used to create containers are another key point. Using official or trusted images from verified sources reduces the chance of vulnerabilities. These images should be minimal, containing only what's necessary, which limits attack points. Regularly scanning images with tools like Trivy or Docker Scout helps find and fix security issues before deploying. Running containers with root privileges is risky. If a container runs as root, it could potentially escalate its privileges and harm the host. Configuring containers to run as non-root users and enforcing policies that prevent root execution makes containers safer. The Docker daemon, which manages containers, has high privileges on the host. Protecting it is vital. The daemon should not be exposed over a network unless necessary, and if it is, strong authentication and encryption are essential. Access to the Docker socket must be tightly controlled to prevent unauthorized commands. Network security is also important. Limiting resource usage, restricting network access, and using secure policies in orchestration tools like Kubernetes help contain potential breaches. Proper network segmentation prevents attackers from moving laterally within the environment. In cloud environments like Amazon Web Services, Microsoft Azure, or Google Cloud, container security integrates with cloud-native tools. Managed container services such as Amazon Elastic Container Service or Google Kubernetes Engine include features like image scanning, role-based access control, and network segmentation. Automating security checks in the development pipeline ensures containers are scanned and hardened before they go live. Overall, securing Docker containers is about following best practices. Use trusted images, avoid running as root, secure the host and Docker daemon, scan regularly, and control network and resource access. When these steps are followed, containers become much safer. This is important because containers often run critical applications. If a container is compromised, it could lead to data leaks, service outages, or give attackers a foothold into your entire cloud setup. Proper security helps protect your data, maintain trust, and keep your cloud environment safe and reliable.